Hi guys, welcome back. Too much. We're gonna set a 2-hour box. Alarm desane. Sorry. So you're there. Okay, sorry. Very good, isn't it? Very good, isn't it? Okay, let's read this. Data structures and algorithm. Data 構造とアルゴリズム。Hi, introduction to algorithms. In this chapter, you get a foundation for the rest of the book. You will write your first search algorithm, binary search. You learn how to talk about the running time of an algorithm, big O notation. You are introduced to common techniques for designing algorithms, recursion. Let's see what kind of LS is this. लग गए मुझे सही पे let's go. Fit to page. Hi. Let's read and hope we learn something. Oh my lord. Oh my lord. Okay. Mom lord. Cha kala la 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 la. Day one is fine right now. Day one. Boom. I don't need this. Sure. Okay, an algorithm is a set of instructions for am I gonna learn something? Okay, let's start. An algorithm is a set of instructions for accomplishing a task. Every piece of code could be called an algorithm, but this book covers the more interesting bits. I choose the algorithm in this book for inclusion because they're fast. I chose the algorithms in this book for inclusion because they are fast, or they solve interesting problems, or both. Here are some highlights. Chapter 1 talks about binary search and shows how an algorithm can speed up your code. In one example, how an algorithm can speed up your code. In one example, the number of steps needed goes from 4 billion down to 32. A GPS device uses graph algorithms, as you'll learn in chapter 6, 7 and 8, to calculate the shortest route to your destination. Okay, you can use dynamic programming discussed in chapter 9 to write an AI algorithm that plays checkers. Now, in each case, I'll describe the algorithm and give you an example. Then I'll talk about the running time of the algorithm in the big O notation. Finally, I'll explore what other types of problems could be solved by the same algorithm. What you learn about performance. The good news is an implementation of every algorithm in this book is probably available in your favorite language, so you don't have to write each algorithm yourself. But those implementations are useless if you don't understand the trade-offs. In this book, you'll learn to compare trade-offs between different algorithms. Should you use merge, sort, or quicksort? Should you use an array or list? Just using a different data structure can make a big difference. What you learn about solving problems? You learn techniques for solving problems that might have been out of your grasp until now. For example, if you like making video games, you can write an AI system that follows the user around using graph algorithms. You learn to make a recommendations system using k nearest neighbors. No idea. Some problems aren't solvable in a timely manner. The part of this book that talks about NP complete problems shows you how to identify those problems and come up with an algorithm that gives you an approximate answer. Most generally, by the end of this book, you'll know some of the most widely applicable algorithms. You can then use your new knowledge to learn about more specific algorithms for AI databases and so on. Or you can take on bigger challenges at work. What do you need to know? You need to know basic algebra before starting this book. In this particular, take this function x2. What is x5? 10. If you answer 10, you're set. Additionally, this chapter and this book will be easier to follow if you are familiar with one programming language. All the examples in this book are in Python. If you don't know any programming languages and want to learn one, choose Python. It's great for beginners. If you don't know another programming language like Ruby, if you know another Ruby, you'll be fine. Hi.js. Nothing here. Binary search. Bitch. Oh, sorry. Binary search. Okay, suppose you are searching for a person in the phone book. What an old-fashioned sentence. Their name starts with K. You could start at the beginning and keep flipping pages until you get to the K's, but you are most likely to start at a page in the middle because you know the K's are going to be near the middle of the phone book. I suppose you are searching for a word in a dictionary and it starts with O. Again, you'll start near the middle. Now suppose you log on to Facebook. When you do, Facebook has to verify that you have an account on the site. So it needs to search for your username in the database, in its database. Suppose your username is Karamagaram. Facebook could start from the A's and search for your name, but it makes more sense for it to begin somewhere in the middle. This is a search problem, and all these cases use the same algorithm to solve the problem: binary search. This is a search problem, and all these cases, the font is very small. Okay, this is a search problem, and all these cases use the same algorithm to solve the problem: binary search. Binary search is an algorithm. Its input is sorted list of elements. I'll explain later why it needs to be sorted. Its input is a sorted list of elements. I'll explain later why it needs to be sorted. If an element you are looking for is in that list, binary search returns the position where it's located. Otherwise, binary search returns no. If yes, if yes, you get it. If no, then no. You get the position, turns the position. I don't know, like position or no. Just what's this? Kramarica Industries, Mendeley Industries, Kramarica Industries in the phone book. Entry 144 and Mendeley Industries. No, looking for companies in the phone book with a binary search. Okay, here's an example of how binary search works. I'm thinking of a number between 1 and 100. Here's an example of how binary search works. I'm thinking of a number between 1 and 100. You have to try to guess my number in the fewest tries possible. With every guess, I'll tell you if your guess is too low or too high or correct. Suppose you start guessing like this: 1, 2, 3, 4. Here's how it would go: 1, too low; 2, too low; 7, too low. A bad approach for 2. Number guessing. This is simple search. Maybe stupid search would be a better term. With each guess, you're eliminating only one number. If my number was 99, it could take you 99 guesses to get there. Here's a better technique. Start with 50. Psh, too low. It's still too low. Damn. These are all too low. Too low, but you just eliminated half numbers. Now you know that 150 are too low. Now guess 75. 75, like initially we had 100 numbers, then we guessed 50. We did like by 2. Now again we're gonna do by 2. So 22, like 50 are left. So 50 are left, so 25, 25, so 75. Now too high. Okay, now it's between 51. I mean it's between 50 to 75. That's too high, so lower. Too high, but again you cut down half remaining. 20, 10, 12. Too high, but again you cut down half the remaining numbers. With binary search you guess the middle number and eliminate half the remaining numbers every time. Next is 63. Of course, 25. 63 too high. Again 63, 50. So 50, and what's this? 7? Oh, 7, yes. So this is a 50, 25, 13, 7. 63, 57. And this is a binary search. You just learned your first algorithm. Here's how many numbers you can eliminate every time. 100 items, 50, 25, 13, 7. Eliminate half the numbers. Eliminate half the numbers every time with binary search. Okay, whatever number I'm thinking of you can guess. Then maximum of 7 guesses, because you eliminate so many numbers with every guess. Suppose you are looking for a word in the dictionary. The word has 240,000 words in the word case. How many steps do you think each search will take? Simple search, yeah, 240, 39,999, like that. 240, I guess. Simple search could take, yeah, if the word you're looking for is the last one in the book. With each step of binary search you cut down with each step of binary search you cut the number of words in half until you have left with only one number. 24k, 240k, 120k, 60k, 30k, 15k, 7.5, 735, 37505. No. 18 steps. So binary search will take 18 steps. A big difference. Damn. A general search for any list of n, binary search will take log 2n steps. Log 2n. It's like that. How do you like? Oh, this. Okay. So if we're gonna like 10, 10, 10, you cannot see that. Oh, you can. So like 10 times. So that's 100. You don't have a n is n, okay. 2 to the power n. So 2 multiplied 2 times n makes it like that. Oh wow. I need to erase it. Psst. Yes. So binary search will take 18 steps, a big difference. In general, for any list of n, binary search will take log 2n steps to run in the worst case, whereas a simple search will take n steps. Oh. In general, for any list of n, binary search will take like 2 to the n times. That's n. Will take log 2n steps to run in the worst case, whereas a simple search will take n steps. Logarithms. You may not remember what logarithms are, but you probably know what exponentials are. Log 10 is like asking how many 10s do we multiply together to get 100. The answer is 2 10, like 2 10 times 2 10 times 10. So what the fuck? Yeah, like 10 multiplied by 10 2 times. Yes, or 2 10 times, 2 10 times. That's wrong. Bitch. Logs are flip of exponentials. Logs. Oh, I was wrong. Okay. 10. Well, I was stupid. Yeah, that's of course. Why did? Okay. 100. Then this is 10. This goes over here. 2. And this goes over here. Like that. Na 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 na. Log A and log A. Stop, shut up. Okay, what's this? You may not remember what logarithms are, but you probably know what exponentials are. Log 10. 10 is asking how many times? 10 10 10 10 10 10 10 10 10 10 10 3 times 2 8 2 2 2 2 2. Okay, multiply 2 until we get it. Oh, 4 times, 5 times. How many tens do we multiply together to get 100? The logs are the flip of exponentials. Logs are the flip of exponentials in this book. When I talk about running time in big O notation explained a little later, log always means log 2. Log 2 in this book, when I talk about running time in big O notation explained a little later, log always means log 2. When you search for an element using simple search, in the worst case, you might have to look at every single element. So for a list of 8 numbers, you'd have to check 8 numbers at the mark. What? In the worst case, you might have to look at every single element. So for a list of 8 numbers, okay, now you'd have to check 8 numbers at most. For binary search, you have to check log n elements. In the worst case, log n elements. Log n. For a list of 8 elements, log 3 times, because 2 because 2 3 times. Okay, 8 boom, 4 boom, 2, there you go, 1. So a list of 8 numbers you'd have to check 3 times. Log n, in the worst case, that's 8 times. Okay. What's okay? It's not okay. And then this log always means log 2. Oh, so for a list of 8 numbers, you would have to check 3 numbers at most. For a list of 1024 elements, you'd have to do 10. What's that? 10 times 2, 10 times like that. So a list of 10 times. Where is 2? Shut up. So for a list of 1024 numbers, you'd have to check 10 numbers at most. Log. I'll talk about log time. I'll talk about log time a lot in this book, so you should understand the concept of logarithms. If you don't, okay. Binary search only works when list is in sorted. Sorted list. Binary search only works when your list is in sorted order. For example, the names in phone book are sorted in alphabetical order. So you can use binary search to look for a name. What would happen if the name weren't sorted? Let's see how to write binary search in Python. The code sample here chooses arrays. If you don't know how arrays work, don't worry, they are covered in the next chapter. You just need to know that you can store a sequence of elements in a row or consecutive buckets called an array. The buckets are numbered starting with 0. The first bucket is at position 0. The second is 1. Third is 2, and so on. The binary search function takes a sorted array and the binary search takes a sorted array and an item. If the item is in the array, the function returns its position. If the item is in the array, the function returns its position. The binary search function takes a sorted array, an item. Sorted array and function and an item. If the item is in the array, the function returns its position. You'll keep track of what part of array you have to search through. At the beginning, this is entire array. What's low, 0, high? What's this? Len list minus 1. What the fuck is that? What the fuck is that? Okay. Low is 0, high is length of the list minus 1. Like that. Okay, each time you check the middle element. So mid becomes like that. Sorry. Const low. What am I trying to do? Let me just look at. Okay, low is 0, of course, and high is going to be length of the list. Length of the array, and minus 1. Okay, and each time you check the middle element. So low plus high. Okay, low is 0 and plus high is the length, and by 2. Mid is rounded down by Python automatically if low plus high is an even number. Guess. Okay, guess new variable. List. Oh, that's our list. Okay, that's the array. Okay, and then the mid is going to be that number. Okay. So if the guess is too low, you update low accordingly. So if guess is low than the item, then low is mid plus 1. Mid becomes the low plus 1 actually. I don't want to like we can have like an array. Const, we can have like list, which okay, array is fine. 2, 3, 4, 5, 6, 7, 8. 8 is fine. So here we are doing let low is going to be 0 and let high is not gonna change, but still high is going to be array dot length -1. Okay, so if now we'll have a mid too, so mid is going to be low plus high, okay, and divided by 2. Console.log, and we're gonna this. You know what? It should. What's the shortcut? Oh my lord. .5. We math dot round it. Round ikana. How about now? How about now? Okay. What you gonna learn now? Ah, it's 4. It's fine now. Oh math. Is an even number, okay. So 1, 2, 3, 4, 5, 6, 7, 8 elements we have. Low is 0, 0, 7. Isn't it going to be +1, bitch? Okay, sorry. Yeah. 0, 1, 2, 3, 4, 5, 6, 7. It's gonna become 6. What's it? What's high? I'm getting high. High. Oh my lord. Okay. तेरी भैंस की मैं इधर से नहीं चला रहा क्या? हट रहा है ma. Stupid ass. So if okay, we're gonna make one more guess. Actually, mid is fine. Do I need to do this like this? So each time you check the middle element. Mid is rounded down. So guess. Okay. Mid is the index. So array and then the mid. Cha manager. तेरी भैंस की अबे क्या ही है तेरी माँ का अबे सॉरी shut up. Okay, guess is 5. So if guess is too low, then on number, let's say like 7, then over low is gonna become mid plus 1. Okay, and if the guess is too low, too high, you update high. Here's the full code. Binary search list. Low, oh man, low, and if the guess is too low, you update high. Here's the full code. Def cut crack. Okay, def, what's def? That's Python. That's function, binary search, list an item we get. Yeah. Then low is 0, high is, what's this? Len list minus 1. I think that's length of the list, and minus 1. While, oh, there is a while loop. Low, if low is lower or equal to high until, oh, that's while loop. Mid, check the middle element. Mid, low plus high. Guess, list this. If guess equals item, return mid. If guess is okay, if guess is higher than the item, bigger than the item, then higher becomes mid minus 1. Else low is low plus 1 and return none. Let's test. Call it list, okay. You go here, boy, and then we just give it up. Okay, we ain't console logging every time. We just make it. We just make it. We just fake it till we make it. We just fake it. Fake it. We're gonna have a while loop which is gonna run until our low is smaller or equal to high. Okay, and bitch, we can have them like over here too. So wow. Oh, sorry. Mid is yeah, that's I got it. What the fuck's isn't that a typo? It is low plus high. Check the middle by 2 divided by 2. I guess is list is this. It's fine, I'll have them over there, boy. Half. Oh, hello, what the Fablo? Ita Fablo? Quattro Petro? Petro? Pimlam Letro? Oh. What's wrong with you? What's wrong with you? If the guess is bigger than the item, higher, bigger, whatever, then we just our low becomes of course. What am I doing? High becomes mid minus 1. Mid क्या होता है तेरा पापा? Okayですか? Okayですか? あなた OK ですか？ Oh my lord. Oh my lord. Oh my lord. Say me my lord. So, OK ですか？ OK ですね。OK ですか？はははははは。OK じゃあ。はははははは。Like that. Ha ha. Okay. So beautiful. If the guess is equal to item, will we just like write down it, boy? Write down the mid. Write down the mid. Ah. La 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 la. La la la. That's the okay index number. Or else we be like oh, we don't care, else we be like I don't care, go eat sandwich. Go eat sandwich, you bitch. Low, mid plus 1. Overall we done. No, null bitch. No, null is fine. Okay, none. It's none. हार्डवेयर की मैं तो ये करूँगा क्या लाइक none. None like that. How about that? Okay, list here, or list is actually don't we have it over here? Did I write LA? Do I have a list? My boy? Okay. Binary search. Hi. mad gas is over there. Ah, 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 lol. Lol is fine. That it already is. Are you kidding me? Ma. Have you lost your mind? Have you lost your brains? Please don't make it hard. That it already is. Lol. Lol index number. Lol index number 6 1 0 1 2 3 4 5 6ですね。We have like 2. Okay, it's just an example. 1 3 5 何これ Shut up. And 7 11 no, shut up. Yeah, put up. Add it to 3. Lock index 2. Boom. Index 1. Oh. 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 Oh, what am I doing? Please don't make it hard than it already is. Than it already is. Than it already is. Exercises. What are the exercise? It already is. Already is. Traveling salesperson. Recap. Okay, if I can finish the first chapter, that's fine. Chapter 2, from chapter 2 starts the real thing. Let's cover this theory. Bitch. मैं तो परेशान हो चुका हूँ भाई बहन के लंड से. Suppose you have a sorted of 128 names and you are searching through it using binary search. What's the maximum number of steps to a type? I 28 by 2 64. Shut up. Or if you multiply 28 बहन तो पता नहीं क्या कर रहा हूँ मैं. What am I doing? Binary search. So that's going to be 28 and then 8 ka 4 and that's 4 and 6 and then 3 2, right? And then 6 2 1 6 8 4 2 1 1 1 2 3 4 5 6 7 7 8 steps. Suppose you double the size of the list. What's the maximum number? Suppose you double the size of the list. This isn't like if the size was n, it becomes 2n now. It's 2n now. What's the maximum number of steps now? This okay. If it becomes if it becomes double of this, so okay, it's gonna take plus 1. Sorry, this was wrong. So 1 2 3 4 5 6 7 8 steps, 7 or 8. Okay, now it's gonna take plus 1, 9 steps. If I doubled it, that's 24. 8 दूनी 16 की 6 हासिल की 25. That's right. 2 1 2 8. Yes. Yes. It's fine. ちょっと待って。 तेरी नजरों लगता है कि धोखेबाजी तुम साथ हो मानो क्या बेदर्द सी बेदर्द है अगर तुम साथ हो गाली निकलवा तो मेरे मुंह से, मैंने गाली नहीं देना, गाली देना लेना वो है, निकल जाती है। Please don't make it hard. Please don't make it. No, I do not know that. Anytime running time. Anytime I want to talk about, anytime I talk about an algorithm, I'll discuss its running time. Generally, you want to choose the most efficient. Generally, you want to choose the most efficient algorithm, whether you are trying to optimize for space, time, or space. Back to binary search. How खाली दिलवाते हो मेरे मुंह से। इसको पता है क्या ये ऐसे हैं बहते हैं। Anytime I talk about algorithm, I'll discuss its running time. Generally, you want to choose the most efficient algorithm, whether you are trying to optimize for time or space. Back to binary search. How much time do you save by using it? Well, the first approach was to check each number one by one. If this is a list of 100 numbers, it takes up to 100 guesses. If it's a list of 4 billion numbers, it takes up to 4 billion guesses. So the maximum number of guesses is the same as the size of the list. This is called linear time. Linear time. Binary search is different. If binary search is different. If binary search is different. If the list is 100 items long, it takes at most 7 guesses. If the list is 4 billion items, it takes at most 32 guesses. 4 billion items. Powerful, binary search runs in logarithms time or log time, as the natives call it, log time. So here's a table summarizing our findings today. 100 times 100 guesses, 4 billion times 1. 100 times 7 guesses. Please, logarithmic time. Run times for search algorithms. Run times for search algorithms. 4 billion 32 guesses. Oh, Logan. Oh, you can see my Goda. You can see my Goda. Goda. Logarithmic time. Logan. You don't need to write that, bitch. Big O notation. No, asymptotic notations. What the heck is that? Asymptotic notations. What? Please don't make it hard. Oh, ignore that. You are studying that. Oh, really? Please don't make it hard. Asymptotic notation. A notation is a set of mathematical tools used in computer science to describe the efficient and performance of algorithms as the input size and grows towards infinity. Towards infinity, it abstracts away machine-specific details like CPU speed and constant factors, focusing instead on the rate of growth. And to guy programmer. What? Nani? Okay, there are three primary notations used to represent different performance bound. Asymptotic, notation is a set of mathematical tools used in computer science to describe the efficiency and performance of algorithms. Computer science describes the efficiency and performance of algorithms as the input size and grows towards infinity. It abstracts away machine-specific details like CPU speed and constant factors, focusing instead on the rate of growth of algorithms time and or space requirements. Big O upper bound worst case, representing the maximum time an algorithm will take for any input size. It ensures that growth rate will not exceed a specific time. What's the Hindi name? I'm a Hindi medium student. बहन के लोडो हिंदी में नहीं ले सकते क्या भाई? है नहीं भाई, इसका मतलब ही नहीं होता. Even Google doesn't know what it means in Hindi. उपगामी, पास रहते हुए भी कभी न मिलने वाली स्थिति. यह गणित और कंप्यूटर साइंस में उस स्थिति को दर्शाता है जब कोई वक्र या फलन किसी रेखा या मान के बहुत करीब पहुंचता है, लेकिन उसे कभी पूरी तरह से नहीं छूता. सुबह राशि Nani? The book you are studying didn't mention that this shit is called as a. My name is 30K, trader gambler. How are you? Asymptotic pronunciation. Symptotic. Asymptotic. Bro, कितना abuse कर रहा है. पहले दिन cram मत के. I'm sure interviewers are definitely gonna ask you explain this shit in Hindi. जो अनंत के पास जाकर स्पर्श करती है. उपगामी, जो किसी मान की ओर बढ़ता है. एल्गोरिदम की समय जटिलता को मापने के लिए उपयोग किया जाता है. यार हिंदी में क्यों नहीं पढ़ाते हैं? अंग्रेजी में क्यों पढ़ना पड़ता है? By Japan with Adi cake video. Shit is serious now. What? What happened with him now? What's up, 30k gambler? Gambler. Big O notation. Big O notation is special notation that tells you how fast an algorithm is. Beige. Who cares? Well, it turns out that you use other people's algorithms often, and when you do, it's nice to understand how fast or slow they are. In this case, in this section, I'll explain what a big O notation is and give you a list of the most common running times for algorithms using it. Bro is doing everything he could to gather kids to do in 5. Really? एक और है जिसमें काइवा हो रही है, मेरा पेट दर्द हो गया से. I want to see that. पहले सीरियस वाली talk in English, bitch. So この人はデータ構造とアルゴリズムをやってる. Dang. Oh shit, this guy is doing data structure. Yes, sir. I am. Okay, let's watch a YouTube video. Akshit says it's good.
You don't like. I want to do a thought experiment with you.
Just like how his into. Damn, I better work hard now. I think your internship should get back to you soon. I want to hear about you for that Japan shit. Yeah, maybe made of this one.
I want you to close your eyes. You do not have to ask any questions. This is very important. If you really want to do something in your life, just trust me on this one. Just close your eyes and hear me out. Imagine कि आप 10 साल फ्यूचर में आगे जा चुके हो and your life is exactly opposite of what you wanted. आप जो जॉब कर रहे हो, you absolutely hate it. You hate the people that are around you. You don't like where you're living and you are not at all happy with what you have. You really hate your life. And एक दिन रात के 3 बजे randomly you open up your gallery and you see a picture of yourself from 10 years ago. और अब आप अपने आप से पूछते हो कि if I could go back 10 years ago in time, आप अपनी पूरी लाइफ बदल देते अगर आपको एक अपॉर्चुनिटी मिल जाती फिर से वापस से. Now you are literally begging to God कि काश भगवान आप मुझे एक अपॉर्चुनिटी फिर से दे दे. Now open up your eyes. Congratulations, you just came back 10 years ago. Out of all of the people that are there in the world, God gave you this opportunity. God gave you this chance, this single last chance. So अब मुझे बताओ कि exactly आप क्या करने वाले हो. सुबह के 6 बज रहे हैं and I'm in front of the camera and I'm trying to record this video. Why am I doing this video? मैं क्या करना चाहता हूँ इस वीडियो के थ्रू? What is the aim of this video? Maybe I want to motivate you. Maybe I want to tell you कि आप लोग क्या अचीव कर सकते हो लाइफ में. I know कि आप में से बहुत सारे लोग हैं जो कि YouTube पे, Instagram पे और ये सारे सोशल हैंडल्स पे, ये जितने भी लोग हैं जो कि व्लॉग्स बनाते हैं या फिर जापान में ट्रैवल करते हैं या फिर जापान में जॉब करते हैं, स्टडी करते हैं, मुझ जैसे जो लोग थे या मुझ जैसे जो लोग आगे भी आएंगे, उन लोगों को देख के आप लोगों के दिमाग में एक एस्पिरेशन आता है कि यार आई ऑल्सो वांट टू गो टू जापान, आई ऑल्सो वांट टू स्टडी देयर, आई ऑल्सो वांट टू डू जॉब देयर, आई ऑल्सो वांट टू ट्रैवल दैट प्लेस, आई ऑल्सो वांट टू चेंज समथिंग अबाउट माई लाइफ.
I've heard this shared like 1,000 times from 100 different videos.
Just ask this one single question to yourself. After watching that vlog, after watching that motivational video, after watching that inspirational video, after knowing that pathway, after knowing that scholarship, what do you do about it? What action do you take? I don't know why in this world people think that it takes some certain
Certified hintayaro.
amount of magic. को भी ये चीज बोली कि मैम देखिए कोई सोर्स ऑफ एवरी सिंगल एम दैट यू सामने वाले को ब्लेम करोगे, सामने वाले पे हंसोगे, बट यू वुड नॉट टेक द कुछ नहीं हो रहा भाई तुम्हारी जिंदगी का, उस गंदे से घटिया से कमरे में बैठ कर रोते रहो और इमेजिन कर नहीं है तो नहीं हो पाएगा भाई.
He's rage baiting people like me.
देख लो दुनिया भर के ब्लॉग, देख लो दुनिया भर की मस्ती कर लो, मजे कर लो, रात को 9 बजे अपनी थाली. एंड मैंने उन्हें एक चीज बोली, मैंने बोला सर आप इस चीज को ऑब्जर्व करिए कि कितना ज्यादा केओस चल रहा है
घटिया कमरा, that
वेस्टर्न कंट्री.
Yeah, that was personal. That was personal.
यहाँ पर सेफ्टी की कोई गारंटी नहीं है, यहाँ पर अपॉर्चुनिटीज के नाम पे पूरा सैचुरेशन पड़ा हुआ है. एवरी सिंगल पर्सन हु वांट्स टू स्टडी अब्रॉड और वांट्स टू डू समथिंग अब्रॉड इज लुकिंग एट जापान राइट नाउ. इंजीनियरिंग करना है, मैं वो कैसे कर सकता हूँ भाई, वो एनीथिंग.
Give me the real one. Why he is describing Yosh? Yosh's future wife is going to ask him to go little more efficient because he's using oil or can, but she wants isn't Ologan better? Isn't O-log and better? Worst case, best case, bubble sort. O1 is constant time. This one is better, right? And then log and I don't know. Wait, I must share that Kaiba one with the students, bro. You'll laugh your ass off. Yeah. Is it in Japanese, the Kaiba? Of course, that is like really like between this batch of students. Okay, it better be good. Better be some good shit. Where is the like from which timestamp should I start? From the starting or Kaiba randomly like from where the Kaiba begins?
Okay.
Share the audio. It's they're not talking.
Camera requirement during the performance you have to keep your camera open. बाद में के ग्रुप में भी ये लिंक डाल रहा हूँ to judge your Japanese skill.
Arigatou gozaimasu, sensei.
From group first and to call Yash-san.
Look at those all.
Hi, konnichiwa everyone.
Hi, konnichiwa, and he is a friend in our role.
Hi, konnichiwa.
Please mute your mic as
どこか知ってる
Yo.
食べ物と飲み物はどこか知ってる
いえ、わかりません。
大変に聞いたらいいですね。
はい、すみません。
どうなさいますか？
食べ物と飲み物はどこですか？
野菜売り場はわかりますか？その隣です。
はい、わかりました。ありがとう。
フランス君、どこの？
あそこの売り場だよ。
あ
あ、あそこです。イエスさん、
はい
でも、どんなラーメンを買いますか？ブルダーラーメンですか？味噌ラーメンですか？
アミシャにはブルダックがちょっと辛いね。じゃあ、味噌よりいいね。
そうですか。じゃあ、これ。
はい。
飲み物は
もちろんコーラよ。
そうですか。What a Bihari pronunciation.
どこにある？
もう持ってる。
辛いのは大丈夫です。
大丈夫です。
緊急地震速報です。
地震だ。逃げてください。早く、こちらへ出口です。
緊
大丈夫か？もちも。
財布はどこですか？私の財布を見ました。
もうどこの？
冗談はやめて。大切な終了あります。
今回、本当にダメだよ。
こんな時にやめてよ。財布を返して。
財布を返してください。カバンを見せていただけますか？
बारे क्या
なんか
OMG एक्सेल क्या रिटर्न प्रैक्टिस भी होता है क्या
誰かが
ちょっと答えてください。
全然わかんない。できたできた。OK。じゃあ、ちょっと待ってね。
अरे देख के बोल रहे हैं
それでは、はい、じゃあ、グループ2の皆さん、始めましょう。
元気ですか？
はい、元気だよ。今日の仕事はとても忙しかった。
アルバイトのことを聞いてもいいですか？
何か知っていますか？はい、新しいレストランがあります。最近読みになりました。今、人を募集しています。
What 18 की देखकर Japanese की pronunciation देख के
週末は大変です。店長は忙しいですから、月曜日に。
ऐसा लग रहा है होमवर्क सुना रहा है
このレストランはどこですか？
あまり遠くないです。ここから歩いて20分です。面接で何を言いますか？落ちてはっきり話してください。
わかりました。頑張りましょう。
性格はもうわかります。簡単です。まだ自信がなくて。
He's disappointed in my though
落ち着いてやってみます。
じゃあ3人で明日行きましょう。
This is a great
わかりま
stuff
した。
3人はレストランの前に来ました。
皆さん、来ましたね。
3人はレストランの前に来ました。
皆さん、来ましたね。
言いました
はい、来ました。
Bro, this guy took 18
ちょっ
right now.
と緊張します。
どうしてこれは簡単ですよね。
よく来てください。大切。
その名前は俺の
はい、
キャン
教えてください。
キャン玉より
第二に話してください。
石川より
ゆっくり話してください。落ち着いてください。はい。
Seems like robots are talking to each other. Google Assistant and Alexa having conversations.
でも何でもできます。
生麦、生米、生卵。生麦、生米、生卵。
いいですね。完璧です。正解です。ポイント1。
正解です。ポイント1。
次はアルペットさん。隣の客は雪かき風客だ。
隣の客は雪かき客だ。
ああ、ちょっと難しいですね。もう一度言ってみてください。
隣の客は雪かき客だ。
おお、いいですね。
正解です。ポイント1。
最後はランジェットさん。すももの口。
नहीं वाला इंडियन आइडल में
फिर ये है मदर एंड नरेटर. So C1 始めましょう。新宿駅友達
11時に10分です。間に合いません。ちょっと待って、切符を買いましたか？はい、水差があります。明日は大切なテストですよ。
一人で泣いています。
急いでください。
Enough. What? What was this? हाथी का मुंह निकल गया ये सुन के. Oh my lord. Yeah. And Phil left the chat. Bruh. It was fucking funny. But this going really hard on in Japan and Mama. Where was I? Not there. Yeah, big O notation is special notation that tells you how fast an algorithm is. Who cares? Well, it turns out that you use other people's algorithms often, and when you do, it's nice to understand how fast or slow they are. In this section, I'll explain what big O notation is and give you a list of most common running times for algorithms using it. Algorithm running times. Hey, how did you do this? I mean, you had to learn all these binary search and all that. How did you do this DSA? I'm not asking about lead code, okay? I'm asking about how did you do DSA? Like from where did you learn all this? Algorithms and about algorithms and the structures, data structures. I'll explain what big notation is and give you a list of most common running times for algorithms using it. Algorithms running times grow at different rates. Bob is writing a search algorithm for NASA. His algorithm will kick in when a rocket is about to land on the moon, and it will help calculate where to land. Yeah, I just learned from IT. I don't like IT. Huffed. This is an example of how the runtime of two algorithms can grow at different rates. Bob is trying to decide between simple search and binary search. The algorithm needs to be both fast and correct. No one hand binary is faster, and Bob has only 10 seconds to figure out where to land. Otherwise, the rocket will crash off. Well, of course, rocket will be off course. On the other hand, simple search is easier to write, and there is less chance of bugs being introduced. And Bob really doesn't want bugs in the code to land a rocket. To be extra careful, Bob decides to time both algorithms with a list of 100 items. Let's assume it takes 1 millisecond to check one element. With simple search, Bob has 100 elements, so the search takes 100 milliseconds to run. On the other hand, he only has to check 7 elements with binary search. Log to 100 is 7. Sorry. Just do read code questions. Yeah, I will do read code too. But you need to learn, like, you don't need. Yeah, I will do read code too. Yes. If it does, how long will it take? If it does, shut up. Let's assume it takes 1 millisecond to check one element. With simple search, Bob has 100 elements, so the search takes 100 milliseconds to run. On the other hand, he only has to search 7 elements with binary search. Log to 100 is roughly 7. So that search takes 7 milliseconds to run, but realistically the rest will have more, like a billion elements. If it does, how long will simple search take? How long will binary search take? Make sure you have an answer for each question before reading on. Running time for simple search versus binary search with a list of 100 elements. Binary search 100 elements. Bob runs binary search with 1 billion elements and takes 30 milliseconds. Log is roughly 32 milliseconds. He thinks binary search is 15 times faster than simple search, because simple search took 100 milliseconds with binary search is about 15 times faster than simple search, because simple search took 100 milliseconds with He thinks binary search is about 15 times faster than simple search, because simple search took 100 milliseconds with 100 elements, and binary search took 7 milliseconds. So simple search will take 30 times 15, 450 milliseconds, right? Way under my threshold of 10 seconds. Bob decides to go with the simple search. Is that the right choice? Is it the right choice? No. No. Isn't it gonna take like 1 billion milliseconds? No, turns out Bob is wrong. Dead wrong. The run time is for simple search with 1 million items will be 1 billion milliseconds, which is 11 days. The problem is the run times for binary search and simple search don't accrue at the same rate. So 100 elements, that's 100 milliseconds and 7 milliseconds. So 10,000 elements, 10 seconds and 14 milliseconds. 1 billion elements, 11 days and 32 milliseconds. Run times grew at very different speeds. At very different speeds. That is, as the number of items increases, binary search takes a little more time to run, but simple search takes a lot more time to run. So as the list of numbers gets bigger, binary search suddenly becomes a lot faster than simple search. Binary search becomes a lot faster than simple search. Bob thought binary search was 15 times faster than simple search, but that's not correct. If the list has 1 billion items, it's more like 33 million times faster. That's why it's not enough to know how long, and that's why it's not enough to know how long an algorithm takes to run. You need to know how the running time increases at the as the list size increases. It's not enough to know how long an algorithm takes to run. You need to know how the running time increases as the list size grows. That's where big O notation comes in. Big O notation tells how fast an algorithm is. For example, suppose you have a list of size n. That guy you showed earlier probably tries selling a course. Yeah, those were his students. And he's selling a course 18k rupees. You can convert that into dollars. 200. That's a lot. $200. $194 to talk like that. I mean, yeah. He's maybe he teaches other stuff too. Who knows? Maybe he teaches some Japanese as well. Big O notation tells you how fast an algorithm is. For example, suppose. ちょっと待ってください。ちょっと待って。So simple search will take. Bob runs binary search with 1 billion items. It takes 30 milliseconds. Roughly 32. He thinks binary search is 15 times faster. And why did he think? Why did he think it's 15 times faster? Okay, I think like 7 7 50 7 8 56 7 9 63 70 15 15 30 15 30 15 15 60 15 15 30 90 15 15 30 15 30 60 15 75 15 90 15 70 15 times, like E multiplied by. So binary search is about 15 times faster than the simple search, because simple search took 100 milliseconds with elements, and binary search took 7. So simply simple search will take 30 multiplied by 15. Whatever. Yeah, stupid. $200, bro. Too much. Give me that much money. Give me that money, and I'll tell you to do one key. Give me half. Big O notation tells you how fast an algorithm is. For example, suppose you have a list of size and simple search needs to check each element, so it will take an operation. The run time in Big O notation is ON. The run time in Big O notation is ON. Factorial time. This is the fastest. Then comes this. Then ON log n, ON square, O2. Then factorial. So the runtime Big O notation is ON. Where are the seconds? Yes, your waifu will like that. O1. I'm gonna do it with O1 speed. I see that. No, I'm gonna do it with ON factorial. So it's gonna take me more time to finish. But the run time in Big O notation is ON. Where are the seconds? There are none. Big O notation doesn't tell you the speed in seconds. Big O notation lets you compare the number of operations. It tells you how fast the algorithm grows. So here's another example. Binary search needs log n operations to check. Log n operations to check a list of size n. What's the running time in Big O rotation? Log n. Log n. So what's the here's another example. Binary search needs log n operations to check a list of size n. What's the running time in Big O notation? It's O log n in general. Big O notation is written as follows: Big O and number of operations. This tells you the number of operations an algorithm will make. It's called Big O notation because you put big O in front of the number of operations. It sounds like a joke, but it's true. Now let's look at some examples. See if you can figure out the runtime for these algorithms. Visualize different big O runtimes. Here's a practical example you can follow at home with a few pieces of paper and a pencil. Suppose you have to draw a grid of 16 boxes. What's a good algorithm to draw this grid? Algorithm 1. One way to do it is to draw 16 boxes. 1, 2, 3 like that at one time. Remember, big O notation counts the number of operations. So O-N, big O notation, if you're gonna write 16, if you're gonna draw like 16 boxes, so big O-N, big O notation counts the number of operations. In this example, drawing one box and one operation, you have to draw 16 boxes. How many operations will it take? Draw one box at a time. It takes 16 steps. Draw 16 boxes, of course. O-N, O16, O-N. What was the running time for this algorithm? O-N, O-N, no. I'm gonna write, I'm gonna draw that. That's 6. No. I was going. Yeah. Max. Yeah. Mama, Ine. It's fine. What's Ine? I'm also talking like those. Ine. Okay. Those. Guys. Trainkan is so excited today. Trainkan is always excited. Trying this algorithm best, right? Follow the paper in this example, folding the paper in this example, or make a big and then part cut 1, 2, 3. In this example, folding the paper once is one operation. You just made 2 boxes. With this operation, fold the paper again and again and again, then unfold it. After 4 folds, you have a beautiful grid. Every fold doubles the number of boxes. You made 16 boxes with 16 operations, with 4 operations. That's log n or log n. So you you can draw twice as many boxes with every fold. So you can draw 16 boxes in 4 steps. What's the running time of this algorithm? Come up with running times for both algorithms before moving on. Come up with running times. You can draw 16. You can draw twice as many boxes with every fold. So you can draw 16 boxes in 4 steps. What's the running time for this algorithm? Come up with this running times for both algorithms before moving on. Algorithm 1 takes O n time and algorithm 2 takes O log n times. Yeah. Ah, I was there. It's not a perfect circle, but you don't see that. You don't see, but it started where it ended, so it's fine. Log not it's fine. की तेरी का log and let me tell you the topics which were in the AS: recursion, hardcode, hash map, a little, trees and graphs, hardcode, dynamic programming. Damn. 完璧な絵を描くことも素晴らしい月の一つだったのでしょうか? It was also in the grammar. I meant to, but grammar and 3, is it alright? We are at this, we both are in 2, so I guess it's alright. Big O notation establishes nobody cares about grammar. If you can speak good Japanese, it's fine. Big O establishes a worst case runtime. Suppose you are using simple search. Big O establishes a worst case runtime. It's okay, but speaking entry and it works. What? Yo, I improved. Yeah. Every week, 2 times I talk with Taiga-san. So Big O establishes a worst case runtime. Suppose you are using a simple search to look for a person in the phone book. You know that a simple search takes O(n) times to run, which means in the worst case you'll have to look through every single entry in the phone book. In this case, you are looking for Adit. This guy, Adit. ये क्या नाम है? This guy is the first entry in the phone book, so you didn't have to look at every entry. You found it on the first try. Did this algorithm take O(n) time, or did it take O(1) time? Because you found the first person on the first try. Simple search takes O(n) time. In this case, you found it what you were looking for instantly. That's the best case scenario, but Big O notation is about the worst case scenario, not the best. Okay, so you can say that in the worst case you'll have to look at every entry in the phone book once. That's O(n) times. It's a reassurance. You know that a simple search will never be slower than O(n) times. It's a reassurance. You know that simple search will never be slower than a one. Ah, big O notation. Big O notation is about the worst case scenario, not the best. So you can say that in the worst case, you'll have to look at every element in the phone book once. That's O(n) times. It's a reassurance. You know that simple search will never be slower than a O(n) times. Ba, 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 ba. Probably the worst Japanese I ever heard is the songs are me hands down. Now everyone sees Nihongo Jozu suddenly. Hi, Nihongo heta desu. Look, Anfield is also Nihongoing. この本の名前は何ですか？聞いたことがない。Oh, are you asking this? It's grokking algorithms. この本の名前は何ですか？何すか？聞いたことがないっす。ないっすか？はい、聞いたことがない。What was the name? Grokking algorithm. It's by an Indian guy. That's good. Second edition book. अंग्रेज भी पढ़ लेते इसको तो. What's this? Attic. Grokking. What's grokking? Grokking. What words is that? What does it mean? A deep learning phenomenon where a neural network suddenly generalizes to new data after a long period of only memorizing training data. Damn. 聞いたことがない。ないっす。Oh, she was from China. Damn, I can't even see. That's a girl's picture. ちょっと待ってくださる？ちょっと待って。ちょっと。Probably a girl, guy in real life. Let me say that. Who knows? Who knows? おそらく女の子。現実では男の子。Note, along with the worst case runtime, it's also important to look at the average case runtime. Worst case versus average case is discussed in chapter 4. It's about worst case scenario. Okay, people, you got that? Yes, sir. Got it. Okay. Some common big O notation, big O runtimes. Here are 5 big O runtimes that you'll encounter a lot. Sorted from fastest to slowest. O1 is the fastest. O1. Oh, it's 1 a.m. O log and first is O1, then O1, then O log and also known as log time, example binary search. O and also known as linear time, example simple search. O and okay, we read till here and then that's it for this, and then we read Japanese. Here are 5 O runtimes that you'll encounter a lot, sorted from fastest to slowest. O log and also known as log time, example binary search. O and also known as linear time, example simple search. O and times log n. O and log n. Example of fast sorting algorithm like quick sort coming up in chapter 4. O and square, example a slow sorting algorithm like selection sort coming up in chapter 2. O and factorial, a really slow algorithm like the traveling salesperson coming up. Suppose you are trying to get rid of 16 boxes again, and you can choose from 5 different algorithms to do. If you use the first algorithm, it will take you O log n time to draw the grid. You can do 10 operations per second. With O log n times, it will take 4 operations to draw a grid of 16 boxes. Log 16 is 4. Okay, 2 multiply 2x 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 2. What? Ima chotto shirabeta ii hon mitai. Why to have fun gambling? Can't gamble today. Damn, market is closed. Another. Oh, ja. Otano shinde ne. Amdi. Your OBS and YouTube, it's my PC is in Japanese, so I mean I have Japanese installed, so it kind of automatically translates your messages, your chat, the chat. Fuck, my English is fucked up. Suppose you are drawing a grid of 16 boxes again, and you can choose from 5 different algorithms to do so. If you use the first algorithm, it will take you O log n times to draw the grid. You can do 10 operations per second. 10 operations per second. With O log n times, it will take you 4 operations to do a grid of 16 boxes. Log 16 is 4, so it will take you 0.4 seconds to draw the grid. What if you have 1204 boxes? It will take you 1 second. No. It will take you 10 operations 1 second. Oh yeah, oh I'm right. To draw a grid of 1024 boxes. These numbers are using the first algorithm. The second algorithm is slower. It takes O and time. It will take 16 operations to draw 16 operations, and it will take 1024 operations to draw to 1024 boxes. How much time is that in seconds? A lot. 6 दूनी 12 6 3 18 बहुत. Here's how long it will take. It would take to draw a grid for the rest of the algorithms, from fast to the slowest. This O log n. Okay. That's linear. That's like O log n. Oh, like that. This is like, wow. I think this is the time. I think this is the time, and I don't know. Okay. To play shogi, like I have to change my mentality of chess player. Possibilities are more than that of in chess. I mean, it's just chess but the pieces you take from chess, like of your opponent, you can use them, and that's so amazing. Like it's so fun. It's so fun. It will take you a few some time to memorize them, like how different pieces move in what directions. But once you get that, also a few of those like pieces, they turn into like more powerful version if they enter the opponent's area, so that kind of thing is also there. Like you can't let opponent take your stronger piece, like if you can drop it anywhere in the mid game block. Like you can't let opponent take your strong piece, like he can drop it anywhere in the mid game. This is main, this is main cool point. Yeah, like in chess, if you lose your big pieces, you're done. But in shogi, it's so different. If you are taking, like if you take down your opponent's big pieces, then you can use them for yourself, and like you also have chance to get your pieces back. So that's so cool. But there are weird rules too, like after you have your opponent's pieces, like where you can put those pieces. Those rules are a bit weird, but in my opinion, like AND game is little easy to do in shogi than in chess. We'll play someday, cause I can see ID Hugh, which is at my level in shogi. What? Yo, I'm playing with the Godan player. What are you saying? You're nowhere near me. I've played several times, dozens of times. Even 3-4 बार तो मैंने हरा भी दिया है. क्या नाम है उसका टाइगर सांग को देखिए भेजता हूँ तुझे I will send you this. This is the screenshot. Boom. Like I only had 12 seconds left. Nah, like he was fast, but I still beat him. He went easy on you guys. No, not this time. Not this time. This time, like he made a bit. He made some mistakes. So cause of that. भाई वो टाइगर रखते हुए भी शो पे खेलता होगा तो मुझे लगता है कि एक वीक में हाना भी आपको बीट है on time. Yeah, मुझे पता I know he's a very strong player, but this time like he made mistakes and cause of that I mean he was not, I don't know like what he was doing, so he made that mistake and then damn it was over for him. I was going to lose this. I know like for like first 2 times he went easy on me, that's why I won. But yeah, मेरे साथ लगाइए देखेंगे. मैं थोड़ी गेम प्रैक्टिस करके. प्रैक्टिस क्या करना है, मैं तो करता ही नहीं. हाँ तो ही चलने देना. एल्गोरिथम स्पीड. Okay, that means log n 3.4 seconds. On log n on square on. Okay, like it's fine. Like this traveling person, salesperson, and exercises we'll do tomorrow. We read till here and then we end. I want to read, yeah, some novel too. There are other run times too, but there are 5. These are the 5 most common. This is simplification. That's simple. On square on factorial. Damn, mari jayega inside so. This is simplification and reality. You can't convert from a big O runtime to a number of operations this neatly. In reality, you can't convert from a big O runtime to a number of operations this neatly, but this is a good enough for now. We'll come back to big O notation in chapter 4 after you have learned a few more algorithms. For now, the main takeaways are as follows. Algorithm speed isn't measured in seconds, but in growth of number of operations. Instead, we talk about how quickly the runtime of an algorithm increases as the size of input increases. Instead, we talk about how quickly the runtime of an algorithm increases as the size of input increases. As the size of input. Runtime of algorithm is expressed in big O notation. O log n is faster than on, but it gets a lot faster as the list of items you are searching through. O log n is faster than on, but it gets a lot faster as the list of items you are searching through. Oh, Okay. What app is that? Shogi Watch? Yeah. I think they have app too, and also the website. Shogi Watch. You can play on that. Practice मतलब अभी तो रूल्स सीखे हैं एक बॉट के साथ. लगाओ मैच लाइक फिर लगाता हूँ. लगा लो मैच फिर लगाता हूँ. अच्छा ये You have a name and give the runtime scenarios in terms of it. You have a name and you want to find person's phone number in the phone. You have a name. You want to find the person's phone number in the phone book. That's log and you have a phone number and you want to find the person's name in the phone. अरे बहन के रंट क्या भाई काली के You'll have to search through the whole book. That's O and is it this fine? Is this fine? Okay, you want to read the numbers of every person in the phone book. You want to read the numbers of every person in the phone book. O and you want to run the numbers of just the age. This is a tricky one. It involves concepts that are covered more in chapter 4. Read the answer. You may be surprised. You want to read the numbers of just the age. This is I don't know. He is O1. ओके इसी मुझे पहले पता होता अनटन के बारे में ऐसे ही मैंने अपनी कान वो गुरुते अरे तब पूछ तो लेता पहले पे मूव करो तो भाई 1 साल पहले पूछता ना तब बताता मूव करो मैं और मैंने टैन भी नहीं करना है तुझे तो मोकरो को कैटालॉग है कैटालॉग उस पर सब पढ़ा है पहले से ही मांगा था ना वो OCR हो रखा है उनका जस्ट क्लिक करना साइट पे जाओ और तेरी मांगा अगर इधर होगी तो सर्च कर कोई भी ये तो वन पीस तुम तो वन पीस देखते हो ना क्लिक करो बुचुड़ क्लिक करो यानी ये इंपोर्ट हो जाता है इधर हाँ यस करना था उसको इंपोर्ट हो जाता है और इसमें भी सेम चीज़ है लाइक यू नो देख इधर देख आंकी भी कनेक्ट करा सकते हो इधर मैं तो नहीं करा था मैंने नहीं करा ना ये ऐसे वाला माना टाइम में भी होता है वैसे तो मैं यूज़ नहीं करता ना वो ऐसा कर सकते हो आप बार अब क्या करें इंसान खतरनाक हो ना आप ओके खतरनाक बहन जो ऐसी गंदी सी हिंदी कौन बोलता है बहुत गंदी रखी है भाई मेरी हिंदी बहुत गंदी लगती है भाई आदित्य वर्मा डीएस से कम बता रहा, एक्चुअली ज़्यादा कर रहा। आई मीन डीएस से तो अब आएगा। मैं अरे भाई मैं इट्स मी हु इज डूइंग दिस slowly. I'm reading it very slowly. It's over and now the DSA starts. I mean there is one more traveling person thing and then DSA starts from here, arrays and all that. But today is fine. Okay, feel a little more. I mean he's like he's gonna just explain the algorithms and all that. That's it. I mean not more than that. For the questions I'm gonna have to do those on my own. He's not telling me what questions I can do. आदित्य जिसने बुक रखी है और कहीं का फ़ोन नंबर ही बताया जा रहा है। टीएस से कब करवाएगा ये ऐसी? अगर तू मोकरो मानाटान पे आंकी कनेक्ट नहीं करता तो फिर कोई वर्ड को कैसे माइन करता है कि मैं मैन्युअली? हाँ अभी तो यही कर रखा है मैंने, मैन्युअली करता हूँ मैं तो। बट मैंने like I already know so many words, so the mangas that I'm reading right now they don't have many words that I don't know, so yeah that's why if some by chance some word comes, like every 2 pages like 2 words come up, so I can mind the manually, one click nahi kar raha. No, it's not like that. I mean I cannot scan the page like this, you know, it's like those are just photos. I don't know, I don't use this. I don't use your Mokuro or Manhattan. I use some other site. Yeah, I don't use any Mokuro. OCR I don't use OCR. That's it. Okay, that's it. 3 hours I spent, but it's fine. More hours doesn't do any harm. We can read now. Yeah, you're right, and I use Manga Fire. Personally I like that site, so yeah. एक तो मैं यहाँ पायरेसी की बातें करता हूँ तो मुझे अब पूरा लगता थोड़ा ना। अब अरे टूट गया मेरा हाथ। मैंने कांद मार दी। डिस्कॉर्ड में भेजा है मैंने नाम मांगा फायर। अब मैंने है ना, मैंने पढ़ लेना है। What's that? Let me see. It's just a site, man. Just a side, nothing more. Manga fire. Fire. Just like your side. Sure. Your manga. Manga Taro? क्या नाम है तेरा का? आनी तारो. उसी की तरह है but for manga only. Far better. It's far better. It has its own reader, built-in reader, so best. It's the best that you can get. It's the best you can get. Okay, I'm gonna start so it is a normal manga reading site, right? No extra features, right? Yeah, I mean, yeah, that's it. There is no OCR in it. That's why I like it. I mean, one is fast. The collection of mangas titles it has, it's very it's massive, and yeah, it's available in Japanese. Also, they have mangas in volumes instead of chapters. Like you can choose chapters or volumes. That's what I like. And then the main reason why I'm using it, because I like this site, because it has mangas in volumes. And the other is I can control the picture. You know, the manga pictures panels are all widescreen, so I can like fade them. That kind of feature. Opacity I can control. Opacity. Yeah, like these are the features that I like, so that's why I use it. Either way, I don't care about OCR. I don't use my brain and recall words instead of OCR. Wait a minute, what was the reader? I need to read now 10,000 words, or I lose. Okay, I will start a manga stream, so then you don't mind words, anime words manually also. Do you mind anime words manually also? No. For anime, I have my setup. One click. I do one click for anime. Anime के मरना थोड़ी ना है. Only for manga is that manual, and for others it's one click. I have Yomi time, so it's fine. Any resource for setting up that? For setting up what? ASB player? Jules. Watch his YouTube video about how to mine anime one click. Jules video. Watch his videos. He's a that's his channel name. You'll get a got it. I'm gonna take a look. Okay, I'm gonna start a new stream. Bye bye. No, bye bye. Be back.